this video we're going to look at the 2016 question 10A for Leaving Cert Applied Maths. So with these questions, as I said, the maths is kind of fairly straightforward once you're comfortable with integration, but all of the questions have a little catch, so you need to read them very, very carefully, and you need to be very comfortable with the basics of kind of linear motion, I suppose. So in this question we have at time t seconds the acceleration a of a particle is given by the equation a equals 8t plus 4. At t equals 0, so that's our first kind of limit of integration, p passes through a point with a velocity of minus 24. Show that p changes its direction of motion only once in its subsequent motion. Okay, well, so let's think about this. We have t and we have v. So we could actually use this to get us an equation for v in terms of t if we set our final time as time and our final velocity as velocity. And what this will allow us to do, it will allow us to get an equation v equals blah 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 with t's in it, so we can get the velocity of any time. Now let's start with that, and then we'll think about the change in direction. So we're looking for a relationship between v and t, so we change a to b dv dt. Is 8t plus 4, that's dv equals 8t plus 4 dt. We integrate both sides, and our limits for t are 0 and t, and our limits here are minus 24 and v. When we integrate that, we're going to get v minus 24 equals 8t squared over 2 plus 4t, and our limits are t and 0. That gives us v minus 24 equals 4t squared plus 4t. So v equals 4t squared plus 4t plus 24. So there's our equation for v, and that's a really important equation because what that allows us to do is it allows us to put in any value of time 1 second, 2 seconds, 3 seconds, and find the velocity of that time. Now let's go back to the question. So show that p changes its direction of motion only once in the subsequent motion. So here you really need to understand, how do we represent different directions in terms of velocity? And they told us that the initial velocity was minus 24. So if it changed direction at any point, its velocity would be a positive number. It could be plus 12 or plus 6 or whatever. So in order for v to change direction, it has to go from a minus velocity to a positive velocity. And it can only change direction, it can only go from minus to positive if it passes a specific point, and that point is when its velocity is 0. So what we can do is we can find the times when the velocity is 0, and all the times when its velocity is equal to 0 are the times when it changes direction. Now if we only get one time that its velocity is 0, that means it has only changed direction once. So I hope that makes sense. Don't be afraid to pause it and replay it again if it doesn't. But let's find the times when the velocity is 0. So that would be 0 equals 4t squared plus 4t plus 24. We can divide across by 4 here to give us t squared plus t plus, oh sorry, should that be equals 0? Actually, hang on, I'm after making a mistake there, I think. This should be minus 24, which means this should be a minus, this should be a minus, and this should be a minus. So apologies for that, but you might have spotted that already. Factorize this, and you can use the guide number if you want, but when you factorize it, you get t minus 2 and t plus 3 equals 0. So we get two answers. We get t minus 2 equals 0, or t plus 3 equals 0, which means t equals 2 or t equals minus 3. Now it said prove that it only changes its direction once, and we have actually proved it because this is a negative time. So we only have one solution for time. So only changes direction. In other words, its velocity is only equal to 0 at t equal to 2 seconds. So we've proved it. Let's have a look at part 2. For part 2, find the distance traveled by p between t equals 0 and t equals 3. Now here again, and this question really tests your kind of knowledge of topic 1, they're talking about distance. They're not talking about displacement. And when we use our equations and we use v dv ds, or v is the same as ds dt, this is displacement. And remember dv ds. Displacement is its distance from a point at that time. So let's go down and kind of think about this. Let's say the object starts here, and let's say its initial speed is minus 24. So it's going to start going in that direction. And let's say at some stage it turns around and it starts going back in this direction. And let's say it takes 3 seconds for it to go from here all the way to here. When we do our equation and when we figure out what s is at that stage, it will give us the distance from here to here. It doesn't give us the total distance traveled, which will be the distance from here to here plus the distance from here to here. So we need to make sure we're aware of that difference between displacement and distance when we're doing this question. So what do we know? We know in the question that it starts at a certain point, and after 2 seconds it changes direction. So it covers a certain distance in the first 2 seconds. It changes direction, and we're asked to find its distance, its total displacement after 3 seconds, or distance after 3 seconds. So after 1 second it's going to go back. So the distance we're looking for, or the distance we're looking for, will be the green arrow plus the green arrow. That's its total distance traveled. So let's go back to our equation for v, and our equation for v was v equals 4t squared plus 4t minus 24. We want to figure out its distance traveled at different times, or its displacement at different times, so we're going to get a ds dt relationship. 4t squared plus 4t minus 24. And we have to use the 4t squared plus 4t minus 24. We can't use the one that we divided by 4 because this is the actual equation. We just did that for factorizing. So ds is 4t squared plus 4t minus 24 dt. I'm going to integrate. Initial displacement was 0. We're looking for the displacement after 2 seconds. And as I said, the reason I'm picking 2 is because we want to figure out this distance first of all. How far did it travel in the first 2 seconds? Or what we could do actually is let's get an equation for s first. Let's get an equation for s rather than doing that. And s in terms of t, that might be better. And then we can use that equation for 2 seconds and for 3 seconds, etc. So this will give us s equals 4t cubed over 3 plus 4t squared over 2 minus 24t. So now we have our equation for distance covered. So let's find the distance covered after 2 seconds. And that would be s equals 4 times 2 cubed over 3 plus 4 times 2 squared over 2 minus 24 times 2. And when you do that in a calculator, you should get an answer of minus 29.33 meters. So that minus tells us that after the first 2 seconds, we've gone to the left 29.33 0.33 meters. Now let's get a displacement after 3 seconds. Sorry, this pen seems to be getting worse. And that's going to be 4 times 3 cubed over 3 plus 4 times 3 squared over 2 minus 24 times 3. And for that you will get an answer minus 18. So this tells us after 3 seconds it now has a position somewhere here, where that is 18 meters from its original, but it's still to the left because we still have a minus here. So the question was, what's the total distance traveled? So it's going to be this distance here plus this distance here, which would be 29.33 minus 18. So our answer then, total distance traveled, is 29.33 plus 29.33 minus 18, which gives us a total of 40.66 meters.